What I will talk today a little bit about our current research in social metabolic research, and we're moving into the direction of resilience and malleability research. I will talk also with Shonali. The others will talk about that in a minute. But before that, I should tell a little bit what we mean by social metabolism. I don't know to what extent you all have been exposed to that. So the basic idea is that societies extract biophysical resources like materials and energy, thereby also using other resources like land, to produce any physical stuff that we are using. So for example, we are now in this building, right? And this is actually a lot of materials that have been extracted, brought up here, piled up in a very specific manner. Yeah? That's what we call material stocks. Yeah? So if you look at this picture, so the resources go into factories, roads, and so on, pile up as structures, physical structures that you may call artifacts, you may call also built structures, machinery, products, are distributed, used up, and in the end they end up as wastes or emissions. They may be to a certain extent be recycled. That's social metabolism, and actually we use this concept now for many decades. We mostly do it by misusing economic statistics to create these representations. And I think it's quite interesting. One important thing here is also to distinguish stocks from flows. So a stock is anything biophysical that is within this system boundary at a certain point in time. Yeah? Whenever it is changing over a period of time, you would call it a flow. So for example, at this moment in time, there's a certain number of people, that's the stock of people. Whenever anybody of us enters or leaves, we have a flow of people across the system boundary of this room. Yeah? So that's, in short, the difference between stocks and flows. Yes, and we have done a lot of research on that, but the key point here is that these resource flows and outflows of wastes and emissions are key to many of the global sustainability challenges like climate heating and biodiversity loss. And you have here an account of the last 120 years of how also the size and the composition. Biomass is the green one, then we have fossil fuels, we have non-metallic minerals, and we have the metals, and of course we have a finer disaggregation. We can look at that, how this has changed globally, and we have this for any country in the world. So the basic home territory for us is the national economy, right? It becomes difficult when you want to move below, and we are trying to do that as well. And you see in this time, for example, life expectancy has improved, population has been growing, economic activity has been growing, like measured as GDP. Basically, I'm a fan of GDP. It's a very good thing. Yeah? It should not be misinterpreted. It's an excellent measure of economic activity. It's a very poor measure of welfare, right? So as long as we don't misuse it, it's a very good thing to have.
But it's ever not being misused.
Yeah, that's it. let's leave that for the discussion afterwards. Yeah? It is being misused all the time. Yeah? I completely agree with that. And you know, this is kind of the outflows, and you see, of course, you have to multiply it by 3.6 periodic to get CO2 from the carbon embodied in the emissions, right? And that's kind of one of the major climate drivers. And of course, also the biomass inflow is a very key thing here, because it creates what we now call the global land squeeze, so the land use competition that leads to biodiversity loss, carbon emissions from land use systems, and all these things. And some people call me Mr. Hump, because I've been working for 3 decades on the human appropriation of MPP, which is what you see here, kind of, which is one way of looking at this land squeeze. We'll not talk too much about that today, but just to know this social metabolism links directly to that, because the biomass you see in the flow chart, yeah, on the last slide, it's the biomass that creates this land squeeze. So there is this linkage here. And this, why are we doing it? Why are we interested in? We are interested in that because this resource use is intimately related with all we do as a society, because whatever we do is related with material stocks we are using. Just think about all the built structures you have been using to come here, the built structures we are using here, like from railway lines, from cars, from motorways, whatever, or machinery, yeah? And all of that can be understood or interpreted as providing certain services that we need for a good life. For example, when we had these social ceiling indicators, they are all related to resource use, because we need the resources to produce or to provide people with these services, right? And this is one way of looking at it. So the stock flow service nexus is you always need stocks plus flows, like we need energy to heat this building, yeah? Otherwise it's useless, or you need energy to be able to ride your train, because otherwise the train will not move, right? So that's one way of looking at it, and this leads to a much broader concept than eco-efficiency, which is just dividing resource use by GDP. And I agree with Wolfgang, here it becomes not so useful, right? In some way, yes, but in some ways, no. And a second way of looking at it, and here a link with Natalie practices, understood that the routine activities taking people through their days, they are also very strongly influenced by this, especially by the stock component, because you know, if you have certain infrastructures in place, certain built structures, they will encourage certain kinds of routines, everyday routines, or others will discourage them. Yeah? And so if we ask ourselves, well, how can we change, for example, consumption patterns, we have to think about what kind of practices certain built structures, for example, favor or inhibit. And I think that's one of the key and of course there's a link to political ecology as well, because when especially the built structures, they are often the result of conflicts, of negotiations, of power games, whether they are built in this way or whether they're not built at all, or whether they are built in a different manner, right? Or whether you invest in railways or in motorways. They're just some simple decisions that are very much contested. So, what I will talk today, I will talk a lot about quantifying, mapping, and analyzing social metabolism, because if you want to link, for example, all these sociometabolic phenomena to society, you need to get to a resolution where you can really do it. Yeah? And this is something we've been struggling with quite a lot, and I can show you where we are at the moment. I'm not satisfied, but we are getting closer, let's put it like that. I will talk about high long-term stock flow consistent representations with a very detailed level, high resolution mapping of stocks. Yeah? I will not talk about, but this is also very much important to what we want to do, and Shonali and Guntra is also involved. You also can link extraction, or the extraction of resources and the emissions to final consumption. So this I cannot talk about because I would take a lot more time. Yeah. We're also doing that to a certain extent, not I myself, but I will talk a little bit about these high with low scenarios. So here the idea is, how can we provide the services we need for a decent life for all, for example, to eradicate poverty and hunger and so on, with less resources. And I can just touch upon that, and I will talk a little bit about the project we are just starting on resilience and malleability, where the key thing is we have to cope with non-linearity, disruptions, conflict. Wars have been mentioned, and this is actually what inspired me to start this project. So with the boring stuff, yeah. So we want to quantify misusing economic statistics, social metabolism, yeah. And especially we are interested in understanding, or actually quantifying, material stocks by end use. So this is more than just accounting for how much concrete we have accumulated in a national economy, but we also want to know how much concrete is in houses and perhaps even in different categories of houses, how much is in bridges and roads and so on. Yeah? So this is the meaning of end use here. Yeah? So we want to be able to distinguish where this goes, and this is not at all trivial, and we are not very good at it at the moment, but we've been working a lot. So the idea is materials flow into the economy. We have crude material production, we have manufacturing and construction sectors, and we then go to the use phase, and there we want to distinguish for what products these materials are used. And this is kind of relatively far from inflow-driven material flow analysis, so where we now have the numbers also in UNEP statistics or in OECD statistics, right? Yeah, so that's what we've been doing in the last 6-7 years. And the culmination is this paper that has just gotten published 3 days ago, I think, or a week ago, which is extremely powerful. So what we do here is basically this. So we have trade, we have industry markets, we have the use phase, and we have the recycling and waste flows. And the level where we do it is at 16 processes, every one of them mass balanced. So for each of those components we do the mass balance. Yeah? We have trade at several levels here. We have the use phase, we have recycling, downcycling, we even have trade in the wastes and the used up products, right? And we have this globally on the country level from 1900 to today. Yeah? For 16 processes, 23 raw materials, 21 stock building materials, and 13 end-use product groups. You would say 13 end-use product groups, this is very little, and I agree. But it is super much when compared to how difficult this is. And the data are not very good, but that's really where the frontier is. Yeah? And just to show some results. So this is the cumulative stocks and the build-up of flows over the last century globally. And you can see these components here. You can see the extraction, the refining, the fabrication, manufacturing, final products, the use phase. Here you also have the 1,000 gigatons of stocks that we have at the planet Earth, which is more than all living organisms on the planet, if you dry them. Dry matter. You have all the waste, you see the level of circularity, which is very low, right? So this is thinking about the circular economy at a level which is usually not done, right? So, and you get results like that. So the total stocks by main uses, machinery, non-residential buildings, civil engineering, and so on. Can't go too much into that. And machinery, short-lived products, note there is this 2 orders of magnitude less. Most of it is the buildings, right? The built structures, not the buildings alone, the built structures, road and stuff, yeah? And you can use it to look at inequalities, for example, in how many tons per capita do we have in buildings, in high income, upper middle income, lower middle income, and least developed countries, yeah, and all of that. So you can do that all. Okay, that's the inflow driven, and then we get to the high resolution mapping, and here we integrate data from several satellites, basically Sentinel-1 and Sentinel-2, with OpenStreetMap to reconstruct material stocks at a very high level of resolution. And in this case, we talk about 10 by 10 meter squares. And in principle, this could be done globally. But in this project, we couldn't do it globally for time resources. But, and there's also restrictions, military restrictions. Yeah, and why is it important to be high level? This is the center of Berlin, and this is how the center of Berlin looks like at the 1 kilometer level. Yeah, you don't get a lot of information here. That's at 100 meter level, it's a little bit better, but this is the only level where you really see something. That's 10 meter. And here you see, for example, the metro lines are the dark red stuff, it's most heavy, like, yeah, and it's got the roads and the buildings and so on, so you can see individual buildings. And that's where you start seeing the structures. Yeah? And we've been doing it for Great Britain and Ireland. We've been also doing it for the conterminous USA. Yeah? So these maps are available. You can also use them. They are free, available online in Zenodo archives and so on. And you can just, for example, you can also separate buildings and mobility stocks. Yeah? And for example, here you see that in London the motorways really stick out of the picture, but also some railway lines, right? So that's the most heavy things. And what we are also doing is we are mapping globally together with German Aerospace the buildings. Actually, the primary data is available 10 meter, but we couldn't publish it at 10 meter for military secrecy reasons, right? So that's why we encountered wars in the project also, because I guess, so German Aerospace has published it on 30 meters, but then they told us, well, on 30 meters we will not get permission, so we went to 90 meters. Right? You could do it at 10 meters. Yeah? And this is wall-to-wall, all land on Earth, right? And you can look at any city you like, and even at the 90-meter level, there's something you can see here. And this means we will have, for each pixel, we know the mass of 5 different buildings, 18 different types of materials. Yeah. So this is massive, and it's also online free on this online on this. The data product is hosted by German Aerospace. Yeah. Yeah, and I think this at least has a resolution where we can start linking it, for example, with political processes, with actors, because some of those are high-rise buildings owned by big companies and so on. So you could start working with that. Globally, it's about half of all the materials that humans have stocked up in these buildings, and the other half mostly is in mobility infrastructures. And we are at the moment also trying to get to 90 meter with the OSM data that is available. Okay, so that's to this question of high with low. Yeah. So the idea would be that you could change social metabolism, let's say, through supply side and demand side measures for futures with high service provisioning, and if you go for the low path, low resource demand. And actually, there's a lot of work going on. A lot of that also organized in the EDITS project run by Adolf Grübler at JASA together with other people, and we are also involved in that. And just a glimpse into that, it's from one of the review papers here. Reduction potentials for material use are up to 80%, yeah, if you provide services in a different manner. This is not just technical efficiencies in, doing the same thing with more efficient motors or something, but it's also providing services in different manners. Same for energy, up to 70% reduction potentials, greenhouse gas emissions up to 100, based on a review of 77 studies published in the Annual Review of Environment and Resources by so that's what would be possible, but the bad news is, and here please switch off all your internet uses at the moment. No, what happens here? I want to show this and not the... come on, it's always the same thing. It's working already, no? Yes. Here you can see how Austria is covered with urban sprawl in the last 45 years. It's one of the most depressing results I have produced in the last years, And this actually, this is what I do not want, so can I go back? I don't want YouTube to spoil my show here. So we start 1975, 1980, yeah? And you see, the fraction of highly sprawled, built-up land has growing dramatically. In 1975, it was probably, so let's see whether I can stop it here. No, I can't, not really. In 1975, most of all built-up land in Austria was low level of sprawl, so meaning dense centers, yeah? And since now we have 3/4 in highly sprawl of the built-up land, yeah. And meanwhile, in the part of Austria where you could build something, I forgot. I think you cannot walk more than a kilometer without getting to a built-up spot, and in most cases it will be highly sprawled. And this means, of course, it's not only the massive resource demand for production or for the construction activities, but it's also resource-intensive practices. For example, for mobility, yeah, you will usually not, I mean, in some cases you can, but in most cases people will not use public mobility or active mobility. They will use cars because that's the way this landscape is structured. They will have big houses, yeah, especially when the kids move out. They have one or two persons in a house with 150 square meters, which is even a pain in the ass to get to keep clean, yeah. Anyway, so the point is, it's not even efficient, but it's it requires more, not less resources. So we are moving away from the high to low pathway. Actually, we are not at all moving towards it. Yeah, and it's a hot potato. Yeah, you know. Yeah, so, and with this kind of high resolution stuff, you can show it. And that brings me to the last one, which is. And actually, I have to tell you the anecdote why I invented this project. Yeah, I was in Yaza 4 months into the war. You know, the full-fledged war. Actually, Russia has started war on Ukraine in 2014, but this was 22. Yeah, and I was at the Scenario Forum, and I heard Jim Ski talk about it, and he said, and I learned that 5% of all scenarios in the scenario database at YASA underlying the IPCC report, 5% have looked at SSP 3 and 4. And you might not know which ones SSP 3 and 4 are, but these are the two world-divided scenarios with the global conflicts, with regional rivalries. So actually the world we live in, so no one had looked at that. And I said, you know, I'm not an IAM guy, so I will not produce the integrated assessment model runs and analyze them, yeah? But I'm doing social metabolism, and I know we are not prepared to analyze this world, yeah? Because, I mean, we have nice things, but all of that is either static and descriptive, or it's linear. But now we are dealing with non-linearity on a big scale, right? We have blocked shipping routes, we have warfare, we have pandemics, we have the climate crisis, and so on and so on. And this introduces non-linear chance events that you cannot deal with the kind of models I've been showing, yeah? So that's what I said, we need something to look at the resilience of social metabolism. And the resilience of social metabolism, so if you have supply disruptions, they hit super complex global supply chains, yeah? Which we at the moment cannot model, we do not really understand. But this has huge impacts in terms of the resource outcomes and the well-being outcomes, and it also has huge impacts on what we can do to change what we call then malleability for strategic reasons, because we wanted to use a word that was not ideologically laden, because we wanted to get the project. But basically, when we want to work towards sustainability, how does that affect this? What are the changes in option spaces we face? So that's kind of what we try to do with this project. And we started it a month ago, so I don't have a lot of results to show. But I can show nice things like this one. Yeah? That's one of the project partners has data on some countries where they are able to look at all relationships, trade relationships between individual firms, and in this case even individual people in this country in 1 year, and then you can start analyzing this network. Yeah? And this just displays, I think, the 10,000 biggest ones, right? So the actual data is much bigger. Yeah? It's people at the Complexity Science Hub. They want to get to complex network systems model at 1-to-1 scale. Yeah? Well, they say they can do it, and I know the guy who is doing it, so I started, well, let's try whether we can do it. This is on monetary data, but we want to get to the level where we can understand the relationship to the physical flows, right? Let's see how far we get. We got a lot of money, we have 5 years to go. Perhaps we will achieve at least something, right? No, I want to. And this is also important because effects in such networked systems are highly nonlinear. And I'll show one example here. And this is a toy model, of course. Stefan has produced it for the presentation. In the end, helped us win this grant. Yeah? But the point here is about supply chains when you have cumulative CO2 emissions. And when one firm changes to a supplier with lower CO2 emissions, you think, wow, good thing, we get to lower CO2 emissions, but what happens is the whole network reconfigures because this supplier sells to somebody else, and in the end you have a new supply chain with different cumulative emissions, and the bad news is after swap of this supplier towards a less CO2 intensive supplier, you have a network emitting more CO2. Yeah? This is a toy model. I have no idea to what extent this is a real problem, but it's not inconceivable that such effects may play a big role. Yeah? And we want to look at them. That's, I can't tell you whether we don't have any real data behind that at the moment, right? So, and then this comes to the part where Shonali plays a big role. We also want to look at malleability of social metabolism, meaning to what extent can it be influenced purposively through policies, and there you have to look at actors, institutions, and all these issues, yeah. And we do three provisioning systems, 6 provisioning systems for 3 service needs: food, shelter, and mobility. And we have a lot of project resources here, so I hope we will discover some interesting options to influence what's going on. So Guntra is also involved. So we have a few people here who try to get to this, and of course power relations are one key thing here. Yeah, scenario narratives and so on. So that's the project team. Shonali and myself, that's the guy doing these absolutely fantastic network models, Stefan Turner. He's head of the Complexity Science Hub in Vienna. And then we have a speaker, keynote speaker of last year, Anke Schafarzik. She's also in this, and we have Fridolin Krausmann at the Institute of Social Ecology, has done a lot of this long-term work. Cornelia Staritz, she's working on provisioning systems from a social science perspective, from an international development perspective. And Stefan Gillium, who is firmly in the social metabolism research field, where he has worked on spatially explicit representations of materials extraction, especially on biomass. Now I'm more or less finished. On biomass and metals, that's his specialty. Okay, so that brings me to the take-home messages. If you have not believed me so far, I hope you believe me now. If not, we can discuss. I think that these resource flows are a key driver of unsustainability. Yeah? Not only climate heating and biodiversity loss, but among them, but many more. And if we want to become more sustainable, stay within planetary boundaries, to say it in different words, we need massive changes in biophysical stocks and flows. The stock flow patterns are linked with provision of services. Yeah? That's key, and if we want to do something about global inequality, hunger, and so on, so that's one of the things where we have to think about how we can create different provisioning systems with different stock flow patterns that supply especially to those who need it. Yeah? Altering and reducing resource flows while maintaining service delivery is possible, but it requires fundamental changes in social practices. So for example, in mobility, having more cycling and walking and having less cars and perhaps more public transit will be one of those things. It can save massive amounts of resources, but it is linked with changes in practices. And this is not achieved by telling people not to drive their cars. If I know anything after 4 decades researching in this field, this is utterly useless. Moralizing and telling people not to do things is not working. Yeah? We need to think about different ways. Yeah? So patterns of build structures may be effective here, and just another example from Vienna. Yeah? In Vienna, car ownership and car use is going down for 1.5 decades now without anybody telling anyone not to use a car, but by having a very good public service system. Vienna is very bad on cycling and walking, yeah, because it's social democratic and they don't believe in bicycles. Yeah? They believe in cars and public transit. Okay, but anyway, but it's going down massively, and it is a level that is a lot lower than the average Austrian level of car ownership. So I think we are now at 370 cars per 1,000 people in Vienna, and we are at 600 cars per person in the Austrian average. I mean, this is massive. And it has come down from almost 400 in the last 15, 20 years. Yeah? So these changes can happen. Yeah, but of course I'm not saying Vienna is a good example. Vienna is bad in many ways, but at least in some ways it's working, right? And for the future, I think we need to think about resilience. We need to think about tipping points. That's another way of saying, well, loss of resilience, where systems tip into a different basin of attraction. So we will talk a little bit about that. Ilona and myself will talk about that a little bit more tomorrow when we introduce the workshop. And these are just questions. I have no answers. We just started the project. Of course, we would like to find the tipping points towards sustainability, but I'm not sure. I don't want to promise too much, but you know, that would be nice, no? Okay, thanks a lot.